This is a presentation on the Group 6 transition metals. PowerPoint slides were made by Clay Sykes, Jennifer Payne, and Thomas Kerr. Chromium is the 24th element on the periodic table. Its melting point is 1900 degrees Celsius. It has the lowest melting point of all Group 6 elements. Chromium's 6 valence electrons are found in both 3d and 4s subshells. The repulsion between electrons causes one 4s electron to prefer the higher energy 3d subshell. Therefore, all 6 valence electrons are unpaired, making chromium paramagnetic. Today, approximately 75% of chromium is used to make metal alloys. Chromium reacts with oxygen to form chromium oxide, as seen in this unbalanced equation, and chromium oxide is often used to plate other metals to protect them from rusting. A common example of this chromium-3 oxide product can be seen in the plating on car bumpers built between the 1930s and 1950s. The +3 and +6 oxidation states of chromium are the most common, though chromium can have oxidation states anywhere from -2 to +6. Chromium-3 oxide is used as green pigment in paints and ceramic glazes, and is the main ingredient in IR reflecting paints. IR reflecting paints are used by the military to paint vehicles in order to give them the same appearance as green leaves. Chromium-6 oxide, seen on the right, is used for electroplating and wood preservation. Chromium +6 compounds are powerful oxidants at low or neutral pH. Chromium-4 oxide has magnetic properties and was commonly used for recording devices such as cassette tapes. It looks like a black microcrystalline powder. Molybdenum is the 54th most abundant element in the Earth's crust and the 25th most abundant element in the oceans. It has a large range of oxidation states from -2 to +6. Molybdenum-6 oxide is soluble in strong alkaline water, forming molybdates. Molybdates are weaker oxidants than chromates, but they show a similar tendency to form complex oxyanions by condensation at lower pH values. Molybdenum also has an extensive organometallic chemistry in its lower oxidation state. These compounds contain molybdenum-carbon bonds. A noteworthy example of this metal in a zero transition state is molybdenum hexacarbonyl. It is noteworthy because it is difficult to prepare and may decompose with exposure to air, but is manufactured in small solid volumes and used as an example catalyst in fine chemical synthesis. Molybdenum also has coordination numbers from 4 to 8. It has 35 known isotopes from masses 87 through 113, 7 of which are naturally occurring. Molybdenum-98 is the most abundant isotope, comprising 24.14% of all molybdenum. The free metal of molybdenum has the 6th highest melting point at 2623 degrees Celsius, which is why it's often used for alloys. The most important role of the molybdenum in living organisms is as a metal heteroatom at the active site in certain enzymes. The terminal step of reducing molecular nitrogen to an ammonia usually contains molybdenum in the active site. In plants and animals, these enzymes use molybdenum bound at the active site in a tricyclic molybdenum cofactor, as seen here. Tungsten is the 74th element located on the periodic table. It is physically shown as a steel gray to tin white metal. Much like molybdenum and chromium, tungsten also oxidizes very easily when exposed to air. Tungsten can have oxidation states between +6 and -2, but is commonly found in the +6 oxidation state. It has the highest melting point of any metal at 3422 degrees Celsius and the lowest vapor pressure. When mixed with aqueous solutions, tungsten can form tungstic acid, also known as wolframic acid. Tungsten is normally extracted from 3 different ores: wolframite, scheelite, and ferberite. Once the ore is converted to tungsten 6 oxide, it can be heated with hydrogen or carbon to produce powdered tungsten. However, due to the melting point of tungsten, hydrogen reduction and pyrolytic decomposition are the best ways proven to extract tungsten. Used in welding because of its hardness to form heavy metal alloys, tungsten is very resistant to corrosion, wear, and heat, which makes it very long-lasting and stable. Tungsten has physical properties that make it extremely hard to break, which explains why it is used for jewelry, drill bits, welding, filament in electric bulbs, and armor-piercing tips in armaments. This concludes our presentation on the Group 6 transition element.